Our first lesson will be on points, lines, and planes. You'll learn to identify and model points, lines, and planes, identify collinear and coplanar points, and intersecting lines and planes in space. Why do chairs sometimes wobble? Have you ever noticed that a four-legged chair sometimes wobbles, but a three-legged stool never wobbles? This is an example of points and how they lie in a plane. All geometric shapes are made of points. In this book, you will learn about those shapes and their characteristics. You are familiar with the terms plane, line, and point from algebra. You graph on a coordinate plane, and ordered pairs represent points on lines. In geometry, these terms have similar meanings. A point is simply a location. A line is made up of points and has no thickness or width. Points on the same line are said to be collinear. A plane is a flat surface made up of points. Points that lie on the same plane are said to be coplanar. A plane has no depth and extends infinitely in all directions. A point could be written as a little dot and then labeled, in this case, point P. It's drawn as a dot, named by a capital letter. A point has neither shape nor size. It is only a location. And writing it in words, we write point P. A line can be labeled with a lowercase letter, at least 2 points to determine a line. We need an arrowhead at each end. The letters representing 2 points on a line or a lowercase script letter. Okay, and that's down here. There's exactly one line that goes through any 2 points. We kind of hit that. Okay, so this could be called line lowercase n, or it could be called line AB with words, or this is read also line AB, or line BA, that's also read line BA with the line symbol above it. Plane is denoted by a parallelogram, and we need at least 3 points to determine a plane. The capital script letter could name it, or 3 non-collinear points. There's exactly one plane through any 3 non-collinear points, and this could be named multiple ways, either with our capital script letter or those 3 letters in any order. So if we have more than 3 points on a plane, then the number of ways you could name it gets really large really quickly. And we know the prefix non means not, so non-collinear means not collinear, not lying in the same line. So likewise, non-coplanar means not lying in the same plane. We find that really often a lot in math to look at prefixes. We're going to start off with our first example, seeing how open-ended geometry can be. They ask us to use the figure to name a line containing point K. There are a lot of different names we can use. We can start off just using that lowercase a that they labeled the line with. There are 3 points on this line, so any 2 of those points can be used to name the line. It does not matter order because lines go forever in both directions. So we have 1, 2, 3, 4, 5, 6, 7 different correct answers. You do not use 3 letters, even though there are 3 points on this line, only 2 are needed. Use the figure to name a plane containing point L. Again, we're going to have many right answers. Starting off really simply, we could just use that capital B and call it plane B. It takes 3 points to determine a plane, so you can use any 3 non-collinear points. Okay, here are 3 possible answers. The letters of each of these names can be reordered to create other acceptable names for this plane. So JKM could be written as JMK, MKJ, KJM, KMJ, and MJK. There are 18 different 3-letter names for this plane, so there are a total of 19 correct answers. You only need to come up with 1. Name the geometric shape modeled by the long hand of a clock. I don't know that it matters, it's the long end of the short end. Okay, now some people will look at, most clocks have a little arrow on there, and they go, hey, that looks kind of like the model we draw for a ray. But it doesn't continue forever. It really has points on both ends. So the best name for this would be line segment, because it has 2 definite beginning endpoints. It has a definite length. Okay, if we have a 10 by 12 patio, The geometric shape that comes to my mind is a rectangle. Or the book's answer was a part of a plane. A plane continues infinitely in all directions, so I would kind of lean towards rectangle myself because this has definite ends. Name the geometric shape modeled by the location where the corner of a driveway, okay, so I've got a 2D there, driveway, meets a road. Okay, so they want this specific location. That is definitely a point because it shows exactly where the two cross. In geometry, point, line, and plane are considered undefined terms because they are only explained using examples and descriptions. Even though they are undefined, these terms can still be used to define other geometric properties. For example, two lines intersect in a point. In the figure at the right, point P represents the intersections of lines A, B, and C, D. Lines can intersect planes, and planes can intersect each other. Draw and label a figure for the following situation. Plane R contains lines A, B, and D, E, which intersect at point P. Add point C on plane R so that it is not collinear with line AB or DE. Okay, to represent a plane, we use a parallelogram and we labeled it R. So we drew plane R. Then we need to draw intersecting lines. We're going to label the first line AB, and the word intersect means to cross, so the second line needs to cross line AB, and the second line was supposed to be labeled DE, and then they intersect at point P. So we can label the point of intersection P. Next it says to add point C on plane R so it is not collinear with either line. So just as long as it's not going to be on either line, C could be anywhere on plane R. So this gives us a little practice in following simple directions. Draw and label a figure for the following situation. Line QR on coordinate plane contains Q at -2, 4 and R at 4, -4. Add point T so that T is collinear with these points. Now just remember, when we plot points, the -2, we're going to go 2 units to the left of the origin, and then the 4 up 4 to plot point Q. And for R, we're going 4 units to the right, and then the -4 goes down 4. And they want it to be collinear with these points, so on the same line. So let's draw in the line. And I'm not using a straight edge, so good luck. Hey, that was pretty good for freehanding. Okay, and so I need to pick a point anywhere on that line. Looks like 0, 2 would work there, and we're going to label that point T. A point has no dimension. A line exists in one dimension. However, a square is two-dimensional, and a cube is three-dimensional. Space is a boundless, three-dimensional set of all points. Space can contain lines and planes. Because it is impossible to show space or an entire plane in a figure, edge shapes with different shades of color are used to represent planes. If the lines are hidden from view, the lines or segments are shown as dashed lines or segments. How many planes appear in this figure? Well, there's one that's represented in the blue here, that's plane S, and then there's another plane that's represented by 3 non-collinear points, and so that's going to be plane A, B, C. So short answer, there are 2 planes. Name 3 points that are collinear. There are only 3 points that are collinear in this diagram. They are A, B, and D. Are points A, B, C, and D coplanar? Well, A, B, and D are collinear, and so when we add one more point, C, they will all lie in the same plane. So yes, they are coplanar. At what point do lines DB and CA intersect? Well, intersect is just a word for cross. They intersect at point A. Two lines will always intersect at exactly 1 point. A line is determined by 2 points. A plane is determined by 3 non-collinear points.